Good afternoon, everybody, and welcome to this introduction to the yield and trend analysis in WATS and skyWATS. My name is Vidar Grønås, and I will walk you through the features and show you some examples on how to use this module. You will all be muted, but there is a chat question tab that you can use to ask questions, and we will try to answer these at the end. Okay, so the first thing I would like to do is to start in our control panel, where we're gonna set some targets and show you how we define some of the processes we're gonna use. So in here you can set up the users, the roles, permissions, and so on, and you have a process menu where you define all the processes that you would like to log data from in the system. So these are the ones that will show up in WATS reporting portal, and you can add and define your own processes. Take care, you cannot delete processes, so once they're added we want to keep them in the system because there may be UUT reports attached to them. You can, however, make them inactive just by clicking this button over here. In the product test operation menu, you can assign products, part numbers, to test operations. This will then be used to calculate our total process yield, and also it will be available in a unit verification report that we have in our operator user interface. You can also define your KPI targets. These are the alarm levels that will be used throughout the reporting portal in the system. So here I've set for the PCBA test and the functional test, I've set some individual warning levels and alarm levels. Okay, we will log out, exit this application, and go into the reporting portal where we will spend the rest of the time during this presentation. So I click the reporting, and the first thing that happens when I log into the system is it shows me my default dashboards. So this is where you typically would start when you want to investigate the data. You would put on here your KPIs, the things that you are most concerned about, like product groups and their yields that you want to monitor, maybe the top repair, you want to monitor your worst yield, and so on. This is configurable by user, and you can make your own favorite dashboard that opens up every time you log in. And the purpose is that when you have your data here, it looks like you are in control of your processes and your manufacturing. You do not have to go in further into the data to look for things. However, in this presentation we're going to look at the yield reports in WATS. So yeah, we have many ways of looking at the data, and yeah, we're going to show you the different ones here. I'm going to start with our product yield. So I click this report. This report will show you how the yield is changing per time period, and you can choose the time period here by a month, per week, per day, per quarter, per year. So in order to run this report I need to fill out this filter, and it has typical things that you would know: which product groups you want to look at, the sites that you want to look at, your part numbers, the revisions of the part number, batch numbers, station names, which test operation you would like to see, and these are as you saw them in the control panel. what type of yield information you're interested in, the first pass, the second pass, the third pass, or the last pass yield. If you want to include repaired units, any type of miscellaneous information you want to search for, and so on. The typical way we do this is that we create some kind of filter with this information that we would like to see again and again, and save it. So here I save the filter, and it fills out my my information, and I can apply it, and it will collect the data that I'm interested in. To save a new filter or to change the filter, you just click this save button, and there are some few options here to say if the time should be static, whether both date and time should be dynamic, meaning you can see the last 8 hours, for instance, no matter what time you run the filter, or you want to see a specific time during a day and date period. For instance, you want to see for one day every time the night shift, for instance. You can set up with dynamic date and static time. Okay, so I got my data, and I see per month. I have data from 2012. I see all the months are listed. I can see the number of units being tested. I can see the pass count, and I can see my yield information. If I expand on one of these, so pick July, I have 699 units, 482 units passed. If I click this, it will show me all the products that were tested in this time period with their total count and the pass count and the yield calculation. You can see they're way below my warning and alarm levels. Okay, if I scroll further down, I see the yield by period, I see the yield by product as graphs. And then the bottom I have what we call a test tail. It shows how many products were tested and passed in which run. So in run number 2 I had 168 units run. You can see as we go further down you have a lot of units being tested, even down to run number 11. In number 6th run, I have 6 units passed. If I click this, it will open up and show me the serial numbers that was run. And if I can expand on one of these, you can see the details for this particular serial number. And for this particular one, you can see that within a time period of only a couple of hours, on the July the 30th, from 7:43 until 9:14 in the morning, it actually failed 5 times in a row until it passed. So what would this tell you about your this product and the quality risk for this particular product? If it has just been retested like this, there is a pretty big chance that it will fail after it has been delivered to the customer as well. One comment about this, we also have a workflow module that can prevent these things from happening, where you can limit the user from retesting the product, for instance. Okay, let me go back into my reports. So next one I want to show is the product by revision yield. So I'm just gonna use my same filter. Just hit apply and pick a part number that I want to explore. This particular report, product by revision, will show me the products and show me the revisions and distinguish between the revisions of the products. So I choose one test operation, the PCBA test, And again, I can see the same time period, and I can see the different revisions of the products that has been tested and how many passed. So this is a way for you to have a look at a new revision of a product being released and see how it compares to the older one. The next report, total process yield. I'm going to run this using the same filter operations again. So this particular report shows me for this time period that I've selected, 2012. The period grouping is monthly. So per month it will show me how many products I started and how many products I finished in the time period, showing you about your backlog and your throughput of your complete manufacturing operation. If these numbers have a big difference, meaning, for instance, you're starting much more than you can finish, it means you have some kind of a throughput problem of your manufacturing, and you need to figure out why you can't keep up with all the new products being introduced and are being pushed through manufacturing. Next one, the rolled throughput yield. So I'm going to fill out the filters here again. I'm going to have a look at one of my part numbers, the OLC 140. Hit apply. Okay. I'm just going to update it with all the part numbers. Okay. Hit apply again. So this particular report shows me for all the product or the processes the product has been gone through. So for instance, a product has been gone through both the PCBA test and end-of-line test. You see the different yield numbers are multiplied against each other. So if you have a process where you have a bad yield on each process, this number will get worse and worse and worse, and it shows the effect of having poor yield in multiple operations. So next we're going to look at the product and test yield. This particular report shows me an overview of everything that has been tested based on the part number, the revision, what operation, and even the software version for the test sequence. It gives me a complete overview of everything for the time period I've selected. So for this year, these are all the products and all the different versions that has been gone through my test system. And the yield is of course listed at the end here. So if we want to have a look at one of my high runners here, for instance the OLC 140C, we can see that for this particular one we had 834 units tested, but only 612 passed, giving us a yield of 73.4%. Now what I want to do next is to try to dive into this data and figure out why this is so low. So what I'll do on this shortcut menu here, I choose the test step yield analysis. So this is a report that gives me an opportunity to investigate which test steps fail and which test step takes the most time in my process, and an overview of all the test steps that I've been run on this product. So it fills out the filters for me. So these are this corresponds to my 834 units I had here. So I mark this and hit apply. So this next picture will show me then an overview of what test step takes the most time. So it gives me a Pareto analysis with my top 10 ones. You can see my island configure is taken up most of the time. It counts for about 80% of all the time for this particular test sequence. So it's certainly an area where you can try to optimize, figure out why is this taking so long. Should we move it to a different place in our program, or could we do it in a different way? Below I see my top 10 failures. So again, a Pareto showing me what test step fails the most. So I see here my read DALI plus output has 70 failures and it counts for 10%. The next one has 70 failures. The power load test has 65 failures. You can see the four first one actually counts for 35% of all your failures. So if you can get rid of these, you will increase your yield by 35%. At the bottom here I see all the times my test steps and sequences have been run. So they're all listed here, every single step that has been is in this test sequence. To the right of my top 10 failures, I have all the individual ones that I can explore further. So if I want to have a look at my top one failure, the read DALI plus output, to see, try to investigate why it's failing, I can click this. You will get this picture showing me all the individual test runs. So each point of this line represents a single serial number. You can see there are a lot of them failing below my lower limit. Here's my high limit and my lower limit. I'm just going to expand the graph to also get every item on the list. I had 834. I want to show you an interesting thing. If I remove the failed measurements, you can see my low limit, you can see my high limit, you can see now all the data, and you can see there are a couple of products that are clearly out of the normal distribution and should probably have failed. These are potential quality risk, but because the limits are so wide, they are not being picked up and failed by the system. Also at the bottom here, at the end here, you will see there are some irregularities on the data. We calculate the ±3 deviations, so we show you where we would have placed the limits if this is your data. So these are the kind of the recommended settings, and these are clearly outside of this. If you want to have a closer look at the test report, you can zoom in. You can find this test report that you're looking for and click it and open it up. So you can see that this serial number eventually failed, but it failed in a different step than what we're looking for here. So it failed in a current measurement. Okay, let's go back to the test step and yield analysis. What I would like to do next is to have a look at one of the other ones, the power load measurement. If I click this, this is also one of my top failures. I have a lot of failures in here, and you can see the reason why is because you are very low or very near the low limit. So there are a lot of them failing at the border of the low limit setting. The ±3 standard deviation based on this data set is in these blue lines that you see here. But the current limit settings are high limit up here and low limit down here. The output of the data should have been in the middle, or the limits should have been changed. But this is an easy way of finding that you are off. The output of this product is skewed towards one of the lines, the low limit. Okay, let's go back to our reporting interface. The next thing I want to have a look at is my process capability analysis. So I pick my initial filter again. I hit apply. And what this report does is that it calculates, just gonna select everything and hit apply. What this particular report is doing is that it calculates the CPK values for all numerical measurements run in my test sequence based on the selection above in this filter. So these are all my my numerical measurements. On the far left side you see a star, and by clicking this star you're selecting this particular step as a favorite, and it can be used on your dashboard to monitor the CPK levels on the dashboard. So you can see here there are many of these selected as favorites and some who are not. So what we do here in a quick way, we try to show you what is good CPK, what is bad CPK, and what is too good CPK. So the red ones are values that we mark as not good enough. The green ones are the one that fits the limits nicely with the data set that this test step is producing. And the blue ones are things that are too good. And if we have a look at some of these measurements, because we calculate CPK with failure and without failure. Hang on, just gonna. Okay, I'm just gonna run this again. So to show you the effect of having some bad measurements in the systems, that is affects the measurement very much. So we calculate without failure and with failure. So you have some down here that are quite interesting. You have bad CPK when all measurements are included, and very good CPK when you take out the failures. And if we have a look at one of these, let's see, pick one, this one, and I open up the report for this, so we can see how it looks like in the yield and trend analysis. So we have the data here, and you can see that this is a pretty nice stable reading. However, when it fails, it goes to 0, and it has a big impact on the CPK. So if I take out the filter the failed measurements, you will see that what's inside the limits. Here's my high limit, here's my low limit. This is my data set. You can see that the limits are too wide for this data set, and this is the advised limits, the ±3 deviations. If I go back and have a look at one of the other ones, you will see more clearly. So if I choose this one, read back low, opens up the same window. I adjust my filter to just bring everybody in the picture. Here's a similar type of measurements. I have my high limit, my low limit and my high limit. I see my data set. I can see some of them are failing, but here are some that are not failing. And if I take out my failed ones, again you will see that these are clearly out of the normal distribution. So although there is something happening here, they're not being failed. These are my recommended limits based on these measurements, so they should clearly be looked upon closer. Okay, a couple of other things to mention. We have an export wizard. So if you want to export some of this data and use a different tool to do some further analysis on it, you click the export wizard. You can choose what type of reports you would like to output. There's a new certificate printout. You can choose UUT reports or repair reports, UUR. What you're looking for, selected steps, everything, header informations, chart data, etc. And you choose the output format. And then you run your filter, and you're ready to export this particular selection. In the control panel, we also looked at setting the KPI targets. Those were shown in the reports, but you can also set or send alarm messages if particular products or process yields drops below a limit that you set. So you can go into the email option, click on the yield monitor. You can create a new item. You can choose what part number, what revision, and so on you're interested in, and you will get a notification when this drops below your set threshold. Okay, that was a quick tour of our tool, the yield and trend analysis. There are more information to be found in our support portal, support.rinco.com. More details on using the reports and running the dashboards, setting up the dashboards. There's also an API available to submit and read reports programmatically if you're interested. And then, are there any questions? Okay, I do not have any questions, so still, if there are anything that you would like to discuss further with us, please send us an email or give us a call. I'll be happy to discuss your application and see if we can help you use the tool as you wish. So, thank you all for attending, and have a great day.